we are going to see the first model. So here there is no non-zero elements in the first column of Routh array. Okay, all the terms will be positive. So this is the characteristic equation. First I will read the question. Using Routh criterion, determine the stability of the system represented by the characteristic equation s to the power 4 plus 8 s cube plus 18 s square plus 16 s plus 5. So first we have written the characteristic equation. Here in this given characteristic equation, the order of s is highest order is nothing but s to the power 4. So the first row we will write it as s to the power 4. You first, that is 1 s to the power 4. So first you are writing 1. You skip this one and you take the next one, that is 18. So 18 s square, next one 5. So first row will be having the elements 1, 18 and 5. Then next one is s cube. S cube. Here you are having 8. Then 16. Okay. This is row 2. Now you check the second row. Here you are having 8 and here you are having 16. So the second, if you divide the second row by 8, you will be getting 1 and 2. So you are getting 1 and 2. Now we are going to construct the next row. This is first row, this is second row, and row 3, that is nothing but s square. So s square is nothing but 1 into 18 minus 1 into 2 divided by 1. This 1. Okay. First element. Next one, 1 into 5 minus, here you are having 0. 0 into 1 divided by 1. Okay, this is nothing but s square. So 1 into 18 is 18, 18 minus 2 is 16. So 1 into 5 is 5, 0 into 1 is 0. So 16 and 5. So the third row is nothing but 16 and 5. Now we are going to calculate the next row, row 4. It is nothing but s to the power 1. So 16 into 2 minus 5 into 1 divided by 16. So 16 into 2 is 32 minus 5 divided by 16. It is nothing but 1.6875. It is approximately equal to 1.7. So next we are going to calculate s to the power 0, next row. It is nothing but 1.7 into 5 minus 0 into 16 divided by 1.7. So we will be getting 5. So this is the first column. In the first column, all elements are positive and there is no zeros. Okay. So the system is stable. So since we are having non-zero elements in the first column of Routh array and there is no sign changes, so all the roots are lying in the left half of a spline and the system is stable. So second case, a row of all zeros. Determine if you are having such condition or if you are getting all rows as zeros, then what you have to do is you have to determine the auxiliary polynomial a of s. Differentiate the auxiliary polynomial with respect to s to get das by ds. Then the rows of zeros is replaced with the coefficients of das by ds. Continue the construction of array in the usual manner. So now we are going for the second model. Okay. So the given characteristic equation is s to the power 6 plus 2 s to the power 5 plus 8 s to the power 4 plus 12 s cube plus 20 s square plus 16s plus 16 is equal to 0. Here the highest order is s to the power 6. So the first row we are creating s to the power 6. So here the coefficient is 1, here 8, then 20, then 16. So we have created the second row. The first row. The second row is 2, 12, 16. row 2. Now we have to calculate the third row. So here you check this row 2. It can be divided by 2. 1, 6, 8. So 1, 6 and 8. Now we are going to create the third row, that is s to the power 4. It is nothing but 1 into 8 minus 1 or 6 into 1 divided by 1. First element. Next one, 1 into 20 minus 8 into 1 divided by 1. Next one, 1 into 16 minus 0 into 1 divided by 1. So we will be getting 8 minus 6 is 2. Here 20 minus 8 is 12 and 16. We are getting 2, 12 and 16. Again it can be divided by 2. We will be getting 1, 6 and 8 for s to the power 4. Now we have to calculate s to the power 3. So s to the power 3 is nothing but 1 into 6 minus 1 into 6 divided by 1. Next 1 into 8 minus 8 into 1 divided by 1. So we will be getting both the elements as 0. So this is the condition. Entire row we are getting it as 0. Now we have to create the auxiliary equation. So here you take, we are getting S3 as S3 row as 0. So we have to take this as S4. So S4 plus 6, 8, S square plus 8. So S4 means you skip the next one, S cube. So you will be getting S square. So 6S square. So you skip the S. What is the next one? The constant. So the auxiliary equation is nothing but S to the power 4 plus 6S square plus 8. Now we have to differentiate this by with respect this A with respect to S. So dA by ds is equal to 4s cube plus 12s. The differentiation of constant is 0. Now this value you have to enter in the place of s cube, sorry S3. S cube we have to put 4 and 12. Instead of 0 we have to put 1 and 3. Actually you have got what? 4 and 12. It can be divided by 4. So 1 and 3. So instead of s cube we are putting 1 and 3. Now we are going to calculate what? S square. S square is nothing but 1 into 6 minus 3 into 1 divided by 1. The first element. Second element is this 1 into 8 minus 0 into 1 divided by 1. So you will be getting S square. 3 and 8. We are writing. Then we are going to calculate S. 3 into 3 minus 8 into 1 divided by 3. So S1 is 0.33. Now we have to calculate S0. S0 is nothing but 0.33 into 8 minus 0 into 3 divided by 0.33. So you will be getting 8. So in the first row, all the things are positive. Elements in the first column of row 3 is observed as there is no sign change. Okay. The elements in the first column there is no sign change. The row with all zeros indicate the possibility of roots in the imaginary axis. So if you are getting all rows as zeros, then it indicates that you are having roots on the imaginary axis and the system is limitedly or marginally stable. How is the system? The system is limitedly or marginally stable. Here the auxiliary polynomial is nothing but s to the power 4 plus 6s square plus 8 is equal to 0. Now you put s square is equal to x. So you'll be getting x square plus 6x plus 8. So if you solve, this is a quadratic equation, you know the roots is nothing but minus b plus or minus root of b square minus 4ac by 2a. By substituting the value, you are getting the roots as minus 3 plus or minus 1. So it is minus 2 or minus 4. The roots of the auxiliary polynomial is s is, but what is s square is equal to x. So what is s? S is nothing but square root of x. So you will be getting square root of minus 2 or square root of minus 4. So 2 can be written as 2 into minus 1 and minus 4 can be written as minus 1 into 4. So root of minus 1 is nothing but j. So it can be written as j into root 2 and this one is nothing but 2j. Okay, so here the roots are having roots on the imaginary axis. The roots of the auxiliary polynomial are also the roots of characteristic equation. Hence, 4 roots are lying on the imaginary axis and the remaining 2 roots are lying on the left half of S-spline. So, this system is limitedly stable or marginally stable.